Hello friends, welcome to VK Lectures. In this lecture we are discussing the Karnataka Set 2020 question paper physics from question number 41 to 60.
Let psi of x be an arbitrary wave function of a physical system and h be the Hamiltonian of the system with lowest eigenvalue denoted by E naught. Now how to find out energy? Energy is nothing but integral psi star h psi dx divided by integral psi star psi dx. Now the denominator is nothing but probability, and psi star h psi dx. This is how you find out energy. Expectation of energy or expectation value of h. So this is nothing but psi star h psi divided by psi star psi. This is the minimum energy. Minimum energy equal to E naught. That means this particular quantity can be greater than or equal to E naught. So your option is option D. A quantum system is in the state 1 by 2 into phi 1, 1 by root 2 into phi 2, 1 by 2 into phi 3. Okay. Now I is 1, 2, 3. These are the states. Okay. Are orthonormal states. What's the question? The probability amplitude for the system to be in state. The probability amplitude is nothing but psi mod psi or psi 1 mod psi 2. Now this is your wave function psi. Now this is your another wave function psi. Let me call it as psi 2. Probability amplitude is means this one. Okay. Now first of all we have to check the psi 1, that is this state is normalized. If it is not normalized, we have to normalize. Now how to check whether it is normalized? Square of the coefficient must be equal to 1. Square of coefficient equal to 1. So let us see, 1 by 2 squared plus 1 by root 2 squared plus 1 by 2 squared equal to, this is 1 by 4, this is 1 by 2, this is 1 by 4. 1 by 4 plus 1 by 4, this is 1 by 4 plus 1 by 2 plus 1 by 4. Half plus half, that's equal to 1. So this is normalized. Okay. Now if it is not normalized, if you have some another value 2 or 3, what you have to do? You just have to divide it by 1 by root 3. Okay. Or multiply by 1 by root 3. Now this is fine. Our wave function is normalized. Now take this value. So 1 by 2 phi 1. You have to see phi 1 and phi 3. So 1 by 2 phi 1 plus 1 by 2 phi 3. Okay, into 1 by root 2 phi 1 plus 1 by root 2 phi 2. Now I have removed this, didn't consider, because there is no phi 2 state here. It is independent of phi 2. So 1 by 2 into 1 by root. So 1 by 2 root 2 plus 1 by 2 into 1 by root 2. That is 1 by 2 root 2. And phi 1 is nothing but 1. That is just like row and column multiplication. So 1 by root 2 plus 1 by root 2, 2 by 2 root 2. So what is left is 1 by root 2. So your answer is B. Which of the following is a possible eigenvalue of the operator Lx square plus 3Ly square plus root 3 into Lx Ly plus Ly Lx? So on your right hand side, what you're seeing is expectation value of Lx square, Ly square and Lx Ly. So expectation Lx square is nothing but h cross square by 2 L into L plus 1 minus m square, and similarly this is Ly squared equal to h cross square by 2 into L into L plus 1 minus m squared. Both are same. Lx square is equal to Ly square expectation. Now coming back, for L equal to 1 and m equal to 0, what are, if L equal to 1, m will be equal to 0, then what is Lx squared? Expectation Lx squared will be equal to h cross squared by 2 into L into L plus 1 is 1. Now similarly Ly squared will be is equal to, this is 2, h cross squared by 2 into L into L plus 1 is again 2. So this is equal to h cross square, this is again equal to h cross square. So here you can write this expectation value is equal to h cross square plus 3 times h cross square, which is nothing but 4h cross square. This quantity will be equal to 0. This one, expectation of Lx Ly and Ly Lx. So your answer is 4h cross squared. So please remember these values: Lx square expectation, Ly square expectation, and Lx and Ly. A two-level quantum system has an energy eigenvalue E plus minus is equal to plus or minus under root E naught square plus E1 square. So here we have a quantum system which has eigenvalues this. So let me write lambda 1 is equal to plus under root E naught squared plus E1 squared, and lambda 2 equal to minus under root E naught squared plus E1 squared. Now the determinant of the matrix will be equal to lambda 1 times lambda 2, which is equal to minus of E naught squared plus E1 squared. Okay, so our matrix formed by this quantum system has a determinant minus of E naught square plus E1 square. Then trace of that matrix will be equal to lambda 1 plus lambda 2, which is equal to 0. So now the question is, this matrix is written in terms of Polish matrices, that means sigma x, sigma y, sigma z, and identity matrix I. Which of the following does not correspond to Hamiltonian of the system? So this matrix, whatever matrix this gives you, H, should have a determinant equal to this particular value and trace equal to 0. So let us see the option one by one. In the first option, you have H is equal to E naught into sigma x minus E1 into sigma z. E naught, this is sigma x, minus E1 into sigma z, which is equal to this minus E1, E0, E0 and E1. Now what is the determinant of this particular matrix? Determinant equal to minus E1 squared minus E0 squared which is equal to minus of E naught squared plus E1 squared. Now take the second Hamiltonian. So this is true, and let us check what is trace equal to. Trace of this matrix is equal to E1 plus minus E1 plus E1, that is equal to 0. Okay, so your option is A is correct. Now check the option B. H equal to E naught times sigma y plus E1 times sigma z, which will give you E1 minus I E naught plus I E naught minus E1, which is equal to E1 that is equal to minus E1 squared minus of I and I into I is minus 1 into minus 1 is equal to plus, so minus again E naught squared, which is equal to E naught plus E1, E naught squared plus E1 squared with a minus sign. And similarly here the trace E1 minus E1, trace is again equal to 0. So your option B is also correct. Now check the option C. H is equal to E naught into sigma y plus E1 into sigma x. E naught into sigma y plus E1 into sigma x. So 0 minus I E plus E1 minus I E naught plus E1. Now here trace is sum of this diagonal element, which is equal to 0. Determinant is 0 minus E1 minus I E naught, E1 plus I E naught into E1 minus I E naught. A plus B into A minus B, that is equal to A square minus B square. I will get squared, so what you are getting is minus of E naught squared plus E1 squared. Again your determinant is same, so option C is also correct. Now check the option D, which is H is equal to E naught times I, identity matrix, plus E1 times sigma z. E naught times I plus E1 times sigma z. This is what you are going to get. Here the trace is equal to E1 and E1 gets cancelled and E naught will remain. E naught will remain 2 times E naught. 2 times E naught. And what is about the determinant? Determinant will be E naught plus E1 into E naught minus E1. So E naught squared minus E1 squared. So this is not true. So so the option D is the correct option, which does not correspond to the given matrix. So this is option D is the correct one. All others give you the same eigenvalues. Three-dimensional harmonic oscillator is in thermal equilibrium with heat bath at a temperature T. The average total energy of the oscillator. If the total kinetic energy was asked, kinetic energy is equal to half kBT. Then for this is for one dimension. For 3 dimension it is 3 by 2 kBT. This is only kinetic energy. Okay. Now what about total energy? Total energy is nothing but twice that of the kinetic energy. So which is equal to 2 into 3 by 2 kBT. So that is equal to 3 kBT. So kB same K, Boltzmann constant. So your option is B. Number of ways in which 5 identical bosons can be distributed in 4 states. Boson. For boson, the distribution function W or omega is given by Ni plus Gi minus 1 whole factorial divided by Ni factorial into Gi minus 1 factorial. And where this is Ni is number of particles and Gi is number of states. This is the same question repeated from 2018. Same question. Now, so what is Ni here? Ni, number of particles, 5. So Ni equal to 5. Gi equal to 4. Right. So Ni plus Gi minus 1. That is 8 factorial divided by Ni factorial. What is Ni? 5 factorial. Gi minus 1 is nothing but 3 factorial. So 8 factorial by 5 factorial into 3 factorial. So your option is D. So please remember this formula from this equation. For bosons, the distribution function omega given by Ni plus Gi minus 1. So number of ways it can be distributed given by Ni plus Gi minus 1 factorial divided by Ni factorial into Gi minus 1, where Ni is number of particle and Gi is number of states. Equation of a state of gas with internal energy U is given by PV equal to 1 by 3 U. The corresponding equation for adiabatic process. So we know PV raised to gamma equal to constant. So our aim is to find this gamma. Okay. Now from this equation PV equal to 1 by 3 U, we can write 3 times PV equal to U. So this is your first law. Thermodynamics says dq equal to du plus dw. Now for adiabatic process, your change in heat is nothing but 0. So du plus dw equal to 0. Now what is d? Du is nothing but 3 times PV. dw is nothing but pdv equal to 0. Now that is equal to 3 times pdv 3 times vdp plus pdv equal to 0. So that's equal to 4 times pdv plus 3 times vdp equal to 0. Now dividing by PV, what you are getting is 4 by V into dV plus 3 by P into dP equal to 0. Now again you can divide by 3 here. So what you are getting is 4 by 3 times dV by V plus dP by P equal to 0. Now you integrate this value. So integrating, you will get, instead of 0 you get constant of integration. Right. Now leave that part. So that is 4 by 3 times integral dV by V is nothing but log V plus this term is log P. Since these two values are in terms of log, we will write this constant also as a function of log C. So this is log V plus log P. Now we can write it in terms of, this is nothing but log V 4 by 3 plus log P equal to log C. So this we can write it as product, log of the product. So log of V log A into log of A into B. Okay, so log V by V power 4 by 3 into P equal to log C. Now you write it as P V power 4 by 3 equal to constant. Cancel out this log on both sides. So PV power 4 by 3 equal to constant. So what is your answer? Your answer is C. Now, but you need not do all these things, because your gamma value is given by 1 plus 2 divided by f, where f is the degree of freedom. Now this quantity gamma is always greater than 1. It can never have a value less than 1. Now there is only one option which is giving you gamma value greater than 1, that is option C. So you need not do all these things, you just need to know what is gamma. Gamma value can never be less than 1. It will be always greater than 1, because f is degree of freedom. Degree of freedom cannot be negative. So this particular quantity gamma is greater than 1. So from there also you can take option C. 48th question. Suppose we have two non-interacting identical bosons, both of the mass m, in one-dimensional infinite square well potential of this is the range of the square well potential, and the wave function, you are asked to find out the wave function when one of them is, that is one of the particle is in ground state and the another particle is in first excited state. Now see, this is the wave function of first excited state, this is ground state. Now what are the possible ways? Either the first particle is in the ground state and the second particle in the first excited state, or the first excited state is having the second particle and the ground state ground state is having the second particle and first excited state is having the first particle. So these are the only possibility. Okay, now so what is psi? Psi 1 is equal to under root 2 by length of the box. What is that? Is a sine of n pi x by a. Since it n equal to 1, pi x divided by a. This is psi 1. What is psi 2? Under root 2 by a sine n equal to 2. So 2 pi x divided by a. So this is psi 1 and psi 2. So here, since bosons are present, bosons, total psi is equal to symmetric. The total psi must be symmetric. That means a wave function psi has two forms. Either it is psi space or psi spin. Okay, together psi space and psi spin must be symmetric. That means if the psi space is symmetric, psi spin also must be symmetric. Or if psi space is negative, that means anti-symmetric, psi spin also must be anti-symmetric. So plus into plus you get plus, that is symmetric. Minus into minus you get plus, that is symmetric. That means together it must be symmetric. Now here the question is incomplete, because one of the state must be given. One of the state of either psi space or psi spin must be given. Only then we can find out the other one. Now here psi spin must be given, because whatever is in the option, it is about psi space. Okay, if the psi spin is symmetric, then your psi space also must be symmetric. Symmetric means you have to use this formula. If psi spin was anti-symmetric, that is minus, then your psi space must be again antisymmetric. Okay, so then you have to use this formula. So here this is psi space plus, that is symmetric. This formula you have been using. This is for antisymmetric. So it depends on the value of psi spin. If psi spin is symmetric, then your option is C. If psi spin is negative, then your option is D. Okay, so from this question we can't say, because either of this psi spin should have been given. So option, it is given in the answer key as C, but D is also possible answer depending on the psi spin. The partition function for a photon gas is given by log z is equal to pi square by 45 into V into kt whole cube divided by h cross cube c cube. The internal energy or the average energy. This internal energy is given by U is equal to minus dou by dou beta log z, or in terms of temperature kt squared into dou by dou t of log z, where beta is nothing but 1 by kbt. Kb is Boltzmann constant. Now, so here it is written given in terms of t. Our function log z is a function depending on t, so we can take the second equation. So u equal to kt squared into dou by dou t of log z. This together is given log z. Partition function is z. What you need in this equation is log z. So here log z is given. So log z is nothing but pi square divided by 45 into V into kt whole cube divided by h cross cube c cube. Now we can take all the constant outside. So kt squared into pi square divided by 45 vk cube divided by h cross cube c cube into dou by dou t of t cube. So that's equal to kt squared pi square divided by, this is 45 into vk cube divided by h cross cube c cube into 3t square. Alright, so here you have k, so k power 4, t power 4, so kt whole power 4. Okay, then pi square divided by this is 3 and this is 45, so that is 1 by 50, and we have pi squared, this is pi squared v by h cross cube c cube into v divided by h cross cube c cube. So your answer is D. Average energy of an ensemble of gas molecules in equilibrium is given in terms of partition function Z by, similar question, internal energy is equal to U equal to, or sometimes it will be written as U bar to indicate average, minus dou by dou beta log Z. This is in terms of beta. If your Z is a function of beta, you can use this formula. Now suppose your Z is a function of temperature, then use this formula. Now beta is equal to 1 by kBT. Now dou beta is nothing but minus 1 by kb t squared. Okay, so kb t squared into dou t. Now just substitute here dou beta here. What you are getting is, so let us substitute that minus dou by dou beta log z is equal to minus dou by, instead of dou beta we will write minus 1 divided by kb t squared into dou t. That is nothing but minus minus get cancelled, so kb t squared into dou by dou t. This is log z, here also log z. So this is how you get two different equations for internal energy. This is kb, Boltzmann constant. A random walker travels along one-dimensional discrete lattice. So minus n plus 1 extra up to 0 and again extra up to n. By putting random steps of length 1 unit. So from 0 to 1 it is 1 unit. Okay, towards left or right. So the random walker has two probability, either left or right, forward, backward. If the initial position is 0, then the probability of finding the walker at 0th position in 6th step is, that means total number of steps he is taking is 6. And what is the probability of finding the walker at 0th position? That means effective step is nothing but where the position is 0. That means he is not taking any steps. That means effective step is 0. Now what is telling is, a person is standing at A, the random walker. He is taking some steps back and forth towards the positive direction and negative direction, or towards left or right. Then after taking n steps forward and backward, he is in the same position, 0th position. So initial position is 0, let me call it as A as 0. Then after taking n steps also, or let me write in terms of this question, after taking 6 steps the walker is at 0th position, which means what? If he has taken 3 steps forward, he should take 3 steps back. Okay, now coming to some ideas about random walk. If n1 is the number of steps forward, let me, instead of forward you can write, with respect to this question you can write it as towards right. n2 is the number of steps backward, this is towards left. Then total number of steps is nothing but n1 minus n2, which is equal to m. So net steps equal to what? 0 with respect to this question. Now what is the total number of steps? n1 plus n2, which is equal to capital N, which is nothing but 6. That means after taking 6 steps, the net steps taken is 0. Now the probability of reaching destination, which is m step away by taking n step. That means total number of steps he has taken 6. The effective step is 0. He is m step away. How much? M equal to 0. Then the probability Pn of m. What do you mean by Pn of m? Probability of reaching the destination which is m step away by taking n step, capital N step, is capital N factorial by n plus m by 2 factorial into n minus m by 2 factorial into 1 by 2 whole to the power n. So that is equal to What is n? 6 factorial. 6 factorial divided by n plus m. M is 0 here. So 3 factorial into 3 factorial into 1 by 2 whole to the power 6. So this is nothing but 6 factorial by 3 factorial, that is 4 into 5 into 6 divided by 3 factorial is nothing but 1 into 2 into 3 into 1 by 2 whole to the power 6 is nothing but 1 by 64. Digital electronics. Okay, so this is 2 into 3 and 6 gone, so 20 by 64. Your answer is 20 divided by 64 divided by 4, 5, sorry 4 you will get 5 divided by 16. So your option D is correct. So please remember this formula from this question. Probability of reaching the destination which is m step away by taking n step is n factorial by n plus m by 2 factorial into m minus n by 2 factorial into 1 by 2 whole to the power n. Now when m equal to 0, this probability is maximum. Maximum probability is when m equal to 0. Which of the following gives statistical definition of temperature in terms of microstate omega? Now a system is said to be in equilibrium when it has attained thermal equilibrium, mechanical equilibrium as well as chemical equilibrium. Thermal equilibrium means temperature is constant. Temperature, or you can also write beta constant. Beta means 1 divided by kBT. So this is how you test the thermal equilibrium. Beta equal to dou by dou E of log omega. That is nothing but 1 divided by kBT. So 1 by T is equal to kB times dou by, instead of E you can write U log omega. That is U is nothing but energy. So from the question your option A is correct. Now for mechanical equilibrium you can write eta, that is equal to dou by dou V of log omega. This is to test mechanical equilibrium, and this eta is equal to pressure by kBT. Pressure by kBT. This is for mechanical equilibrium. Now for chemical equilibrium you can write zeta equal to dou by dou n. Dou by dou n. N is number of particles of the state, and log omega. Dou by dou n of log omega. And eta is given by, eta is equal to mu by kBT. So beta equal to 1 by kBT, eta equal to P by kBT, and zeta equal to mu by kBT. And what is mu here? Mu is chemical potential, and P is nothing but pressure. So these are the different standards for measuring equilibrium: thermal equilibrium, chemical and mechanical equilibrium. If omega denotes number of microstates and V and U are volume and internal energy, then which of the following gives statistical definition of pressure? Now we have already discussed eta. So what it will give? It will give the mechanical equilibrium. Okay, so mechanical equilibrium eta equal to dou by dou V of log omega. Now you can substitute for eta. What is eta from this equation? Eta equal to P divided by kBT. So P by kBT equal to P by kBT equal to dou by dou V of log omega, or you can write P is equal to kBT times dou by dou V of log omega. So what is your answer to P? Kt times dou by dou V of log omega. So your option D.
A photon gas with internal energy U is described by the following equation of state. Now, on the right hand side, what you are seeing is the thermodynamic state functions for black body photon gas. Okay, so internal energy is proportional to T to the power 4, particle number is proportional to T cube, and chemical potential is 0. Pressure, or you can write PV, is equal to 1 by 3 U. Entropy is 4U by 3T, and it is proportional to T cube. Enthalpy is 4 by 3 U. Okay, Helmholtz free energy is A equal to minus 1 by 3 U, and Gibbs free energy is 0. Now, from the question you can write this, you can take this here, pressure. So P is equal to 1 by 3 times U by V, or you can write PV is equal to 1 by 3 U. So your answer is option A.
An ideal gas undergoes isothermal expansion. The entropy of the system is given. So this is your PV diagram. This is V1 and this is V2. So volume is increasing. Now from first law of thermodynamics, first law, dq equal to du plus dw, and what is dq? Dq is TdS, du is ncv dt, and dw is pdv. Now since it is isothermal expansion, isothermal process, your internal energy, change in internal energy equal to 0, because change in temperature equal to 0. So you can write our first law of thermodynamics as dq equal to dw, or you can write tds is equal to dw, or ds is equal to integral, or yeah, dw divided by t. Okay, now you want entropy. Entropy S is equal to integral dw divided by t. Okay, now that is nothing but work done divided by time, sorry, temperature. So entropy equal to work done by temperature. Now work done in isothermal process is given by work done equal to nRT log V2 by V1, or V final divided by V initial. Okay, so what is entropy? Entropy is nothing but work done by temperature, that is nR log V2 divided by V1. This is what your answer is, nR log V2 divided by V1. This is the change in entropy. So please remember these equations from thermodynamics, and as well as the work done in isothermal process.
Here you have the 56th question, that is, if a PN junction is formed having a junction potential Vj and depletion region width W, that is width of the depletion region, then which of the following is true? That means we have to find the relation between the junction potential and the depletion region. Now the equation is given by W is equal to 2 epsilon by Q into 1 by Na plus 1 by Nd into Vbi. Now what is Na is? Na is the doping concentration. Doping concentration on acceptor side. Okay, acceptor side, and Nd is doping concentration in donor side. Okay, yeah. Then VBI is the barrier potential. Barrier potential. Okay, fine. So here we can write W is equal to root of, so junction potential we need to know, so that is BI root of VBI, barrier potential. Now since W is proportional to root of V, we can write V is proportional to W square. So which of the following is giving you the answer? C. That means Vj is proportional to width square. Fine. Question number 57. Now let us understand the each term given in this question. So op-amp has a amplifier has a gain of 10. So this is closed loop gain ACL, which is equal to 10, and the corresponding frequency, that is we will represent it by F2, is equal to 1 megahertz. Okay. Now there is a quantity called gain bandwidth. Gain bandwidth, which is denoted by the letter GBW, which is given by GBW is equal to the gain times gain into the frequency F2. So what you are going to get is GBW equal to gain into F2. Gain is nothing but 10 into 1 megahertz, the frequency megahertz. So that's equal to 10 megahertz. So this is the gain bandwidth, or it is also represented by F unity. Okay, somewhere you may find it as F unity. This is a constant quantity. That means this GBW and F unity is a constant quantity. Now you are asked, the second part of the question says, what will be the gain if the bandwidth is 10 megahertz? That means what is 10 megahertz now? This becomes F2, and you are asked to find out the gain ACL, closed loop gain. Now from this equation, that this is let us put it as equation 1. From this equation you are asked to find out gain, right? So gain, which is nothing but ACL, that is closed loop gain, is equal to GBW divided by F2. Now what is GBW? That is nothing but our F unity divided by F2. Now what is F unity? We have found out it is 10 megahertz. And what is the frequency? The new frequency is 10 megahertz. So this is 10 megahertz. Now what is the answer? 1. So at 10 megahertz your gain will be equal to 1. So ACL equal to 1. So your option A is 1. Question number 58. A square wave of peak to peak amplitude of 500 milliwatt has to be amplified to a peak to peak amplitude of 4 volt with a rise in time of 3 microsecond or less. The op-amp used should have a minimum slew rate of. Now let us understand what is slew rate. Slew rate is the measure of how fast the output voltage changes with respect to time, and this is given in terms of volt per microsecond. Usually volt per microsecond is the unit given, or volt per time. Now that means from here in this question you have 500 millivolt to 4 volt. This is the idea, that is 500 millivolt is nothing but 0.5 volt to 4 volt. Now what is the slew rate formula? V2 minus V1, that means the final voltage minus the initial voltage by time. So V2, that is the final voltage, is 4 volt minus initial one is 0.5 divided by what is the time taken, that is 3 microsecond. So 4 minus 0.5, that is 3.5 divided by 3 microsecond, this is 3.5 volt. So it will be almost 1.1 volt per microsecond. This is your answer. So option D.
Question number 59. The first order low pass filter has a band pass gain of 10 and the cutoff of 10 kilohertz. The gain of the circuit at 100 kilohertz in decibel is given by which of the following options. Now before going to the question, let us understand a few things. Here you have the frequency response curve. On x-axis you have the frequency, and on y-axis you have the gain in decibel. Now how is gain in decibel given? Gain in decibel is given by 20 times log to the base 10 of AV, that means the gain, general gain. Okay, now from the question we have the gain is equal to 10 gain in decibel is given by 20 log the base 10 of 10, that is nothing but 20. This is 20 decibel. So this point is 20 decibel. Fine. Now at 1 by root 2 times the voltage gain, 1 by root 2 times the voltage gain, let us see what is the gain in decibel, that is 20 log 10 of 0.707. This value is equal to minus 3 decibel. That means at 1 by root 2 times the when the voltage or the gain is 1 by root 2, then the change in decibel or the gain in decibel is minus 3. That means as it get reduced, there is a reduction in gain of 3 decibel. It got reduced to 3 decibel. Now here you have a slope. The slope is nothing but 20 decibel per decade. 20 decibel per decade, that means minus 20 decibel per decade. Now what does this mean? This means that for every 10 times increase in frequency, the gain in decibel, in decibel reduces by minus 20 decibel. That means if the frequency increases by 10 times, the gain reduces by minus 20. Now at this point you have the gain of 17 decibel. Now and that particular point is the where you have the frequency of 10 kilohertz as given in the question. Now the frequency is moved to 100 kilohertz. That means from 10 to 100 there is an increase of 10 times. So when it from here at this point A to point B, there is a frequency increase of 10 while there is a reduction of 20 decibel, minus 20 decibel from 17 decibel. So 17 minus 20 decibel is equal to minus 3 decibel. That means when the frequency reaches 100 kilohertz, the decibel, the gain reduces to minus 3 decibel. So for the 59th question we have the answer as option D, which is minus 3 decibel. The gain in decibel is given by 20 log AV. Now what is this AV? AV is V out by VE.
An ideal differentiator using an op-amp has a high frequency gain above its maximum frequency, varying as. Now above its maximum frequency means somewhere here is its maximum frequency comes. Okay, so when you see the frequency response curve, somewhere here it increases and it becomes constant and then comes down, right? Now actually this is the maximum allowed frequency, this is the minimum allowed frequency. Now in this area it is plus 20 decibel per decade. Okay, and after this area it is minus 20 decibel per decade. Okay, all right. Now what is a decade means? Decade is a tenfold increase in frequency. For example, if your frequency, initial frequency is 10 and it becomes 100, this is called 1 decade. Now 20 decibel per decade, it means that the magnitude changes around 20 decibel whenever the frequency changes tenfold. That means the magnitude of the gain changes by 20 decibel whenever our frequency changes from 10 to 100 or tenfold. This is meaning the meaning of 20 decibel per decade. Now here the option is option A, 20 decibel per decade. This is when it is decreasing, this is when it increases.